Floats are used everywhere in wire, and it is by far the most common data type, so you should know all about it. So what is a float? Float is short for floating point number, which basically means that it is a value, either positive or negative, with a decimal point. In the last tutorial, we played with the rectangle node, and here it is again. The value boxes that we are dragging are floats. When I hover above the width inlet of the rectangle, you can see that its current value is 0.5. We can also see that this value should be above 0. We can change this parameter by hand, by creating a float node or by creating a node that generates floats as an output. I'll create a float in node and connect it to the width inlet. Now I have a slider that controls the width. I can increase the range of the slider in the inspector. Here I can also rename the node to, let's say, width. Because this is an input node, it will show up as a user-controllable parameter when running this patch in Arena or Avenue. We'll get in depth on how this works in the integration tutorials. Instead of creating a slider, we could create something that generates values for us. A good example of this would be an oscillator. First, I'll make a transform node, like we did in the previous tutorial, and connect the rectangle to it. Next, I'll create a sine oscillator and connect it to the rotation inlet of the transform node. Now we have automated rotation. Hovering over the outlet of the sine oscillator, we can see that this node provides a continuous stream of floats running from -1 to 1. This triangle node wants a different kind of float, namely a float 2. Float 2 is often used for x and y positions. To create a float 2, we use the pack node to pack two float values into a float 2 value. Now I can use the two float-in sliders to control the x and y position of the point A of the triangle. This fractal noise node wants a float 3. The pack node is used again to create this float variation. Note that you do not need to use all the inlets. Here I keep x and y at 0 and use a sine oscillator to modulate the z parameter. The float 4 variant is most commonly used to construct colors. The x, y, z, and w of the pack node translates to RGBA channels of a color. Here we create a color out of 3 sliders for the RGB channels while keeping the alpha at 1. The opposite of pack is the unpack node. You won't need this node often, but it's good to know it's there. The unpack node will take a float 2, float 3, or float 4 and unpack it into separate float values. Here I use it to extract the RGBA values as separate floats from a color. You have just learned how to work with the most common data type in wire. Congratulations! We have already briefly touched on oscillators in this tutorial. Before continuing to the next tutorial, I suggest that you read the article on oscillators on our website and play around with all the different kinds of oscillators that are available in wire. After you have done that, you can continue to the next video.